What does it take for a country that once couldn't build a single transport plane on its own to develop one of the world's largest strategic airlifters? In the 1960s, China couldn't manufacture a basic turboprop without foreign blueprints. Today, the Y-20 carries 66 tons of cargo anywhere the mission demands. But the real story isn't the aircraft that changed everything. It's the decades of borrowed wings that made it possible. In the early 1960s, China's transport capabilities depended entirely on Soviet blueprints. The Harbin Aircraft Manufacturing Corporation, or HAMC, took on the task of building the Y-7, a twin-engine turboprop licensed from the Soviet Antonov An-24. But as the Sino-Soviet split deepened, Soviet technicians packed up their designs and left. Harbin's engineers suddenly faced severe quality control shortages, lacking everything from proper hydraulic seals to standardized avionics. Forced to manufacture replacements with inconsistent local tolerances, the workforce learned the fundamentals of aviation manufacturing entirely on the shop floor. That trial by fire escalated in the 1970s with the Y-8, a much larger four-engine medium transport based on the Antonov An-12. Scaling up production exposed massive technical gaps. Engineers struggled with multi-engine synchronization, which caused severe vibrations and forced repeated redesigns of the engine mounts. Worse, the high stresses of the new high-wing design caused early fatigue cracks in the wing spars, demanding structural reinforcement before the aircraft could safely fly. Despite these early failures, the Y-8 entered service with the Air Force in the mid-1970s. State planners and military leaders now had a functional medium-range cargo and troop transport. More importantly, the struggle to build the Y-7 and Y-8 transformed Harbin from a mere assembly plant into a capable aerospace anchor, turning borrowed designs into the foundation of a self-reliant industry. Away from the main manufacturing hubs, vast stretches of China remained entirely cut off by mountains, high-altitude plateaus, and a complete lack of paved roads. Larger transports could not operate here. To connect these remote areas, the Harbin Aircraft Manufacturing Corporation developed a class of smaller, rugged utility planes designed to fly where ground infrastructure did not exist. The first answer was the Y-11, a twin-piston utility aircraft that entered development in the mid-1970s. Weighing just 3.5 tons at takeoff, it could carry 900 kilograms of cargo, or 9 passengers, operating from unpaved runways shorter than 500 meters. Its simple design made it a rugged lifeline for remote mountain communities. To expand this utility, engineers designed the Y-12, upgrading to twin turboprop engines and a strengthened airframe. The Y-12 carried up to 19 passengers, or nearly 2 tons of cargo. Its reinforced landing gear allowed it to land on dirt, grass, and ice, transforming daily logistics and medical evacuations in isolated regions. But the limits of this light transport family became clear with the Y-14. Planned as a larger short takeoff and landing transport with a 3-ton payload, the project struggled with a lack of mature domestic engines and rising development costs. In 1988, state planners canceled the Y-14, choosing to focus resources on upgrading the proven Y-12 rather than pursuing a costly intermediate platform. In 1999, Shaanxi Aircraft Industry Corporation began redesigning the medium transport platform to solve a lingering operational limitation. While the older Y-8 moved cargo, modern warfare demanded an aircraft that could act as a host for complex electronic systems. The result was the YM-9, a modernized, stretched airframe designed to carry heavier payloads while functioning as a modular mission platform. Engineers extended the fuselage and strengthened the wing root junctions using lightweight composite materials. They replaced older power plants with 4 WJ-6C turboprops, each delivering 5,100 horsepower to drive 6-blade JL4 propellers. They installed a digital flight control system and updated the avionics suite, turning a basic cargo hold into a highly adaptable interior. This structural flexibility allowed Shaanxi to expand past simple logistics. By adding specialized electronics, radar pods, and sensors directly into the airframe, the Y-9 evolved into a family of dedicated specialist variants. It became the foundation for airborne early warning platforms like the KJ-500, electronic intelligence collectors, and anti-submarine warfare aircraft like the Y-9Q. With these systems aboard, the transport plane ceased to be a simple delivery vehicle. The Y-9 became a platform-level tool, coordinating real-time operations, tracking undersea targets, and securing airspace. This shift converted the medium transport into a critical node within the country's broader military aviation ecosystem, proving that adaptability and specialized mission capabilities could be just as valuable as raw carrying capacity. In the early 2000s, the state-owned aerospace sector expanded its focus from military logistics to global commercial markets. The Aviation Industry Corporation of China, AVIC, launched a dedicated civil aircraft push to capture thin, underserved regional routes. The baseline for this effort was the MA-60, a twin turboprop airliner designed to carry 50 to 60 passengers. Derived from the older Y-7 platform but extensively modernized, the MA-60 used Pratt & Whitney Canada PW127J engines to cruise near 430 kilometers per hour. By targeting short-haul operations in developing nations, the aircraft secured over 300 orders, establishing a commercial footprint across Asia, Africa, and Latin America. To build on this foundation, engineers developed the MA-600, which rolled out on June 29, 2008. Instead of rebuilding the platform from scratch, AVIC focused on iterative refinements. They integrated a Rockwell Collins ProLine 21 digital flight deck, optimized the structural weight, and improved the cabin interior. Reaching a service ceiling of 7,622 meters, the MA-600 proved the manufacturing lines could deliver enhanced efficiency and modern standards. The family's newest commercial ambition took shape with the MA-700, announced in 2013. Designed as a clean-sheet 70-seat regional airliner, the aircraft incorporated fly-by-wire flight controls and advanced composite materials. Engineered with a cruise speed of 637 kilometers per hour and a single-engine ceiling of 5,400 meters, it targeted high-altitude, short-runway routes, attracting 285 intended orders by early 2020. This civil branch transformed transport development into a broader campaign for regional connectivity and international export credibility. In 2006, the Aviation Industry Corporation of China, AVIC, and its subsidiary, Xi'an Aircraft, took on a major project to build the country's first indigenous heavy-lift strategic transport. Designated the Y-20, this high-wing aircraft was designed to break the country's reliance on foreign-built designs. The program aimed to field a platform capable of carrying up to 66 tons of outsized military and humanitarian cargo. including main battle tanks and heavy engineering equipment, over a 7,000-kilometer range. Developing the large airframe required mastering carbon fiber composites to construct the wing skins and ribs, as well as pioneering three-dimensional printed titanium fittings to reduce overall empty weight. On January 26, 2013, the first Y-20 prototype took off from the runway in Xi'an, powered initially by imported Russian D30KP2 turbofans, but strategic autonomy demanded a domestic power plant. Engineers designed the WS-20, a high bypass turbofan that delivers greater thrust and improved fuel efficiency. By the early 2020s, serial production Y-20B airlifters, equipped with these domestic engines, began entering active service, establishing an independent, heavy-lift backbone that altered logistics and global reach. To translate this massive lifting power into extended global reach, engineers developed the Xi'an YY-20. Entering service in late 2021, this aerial refueling derivative replaces cargo space with internal fuel tanks and sub-wing refueling pods. Instead of simply transporting equipment, the YY-20 functions as a force multiplier, transferring up to 3 tons of fuel per minute to receiving aircraft. During early trials, the tanker completed a 13,000-kilometer non-stop flight, proving it could extend the operational radius of stealth fighters and bombers by over 30%. This capability shifts the transport fleet from a logistics tool into a strategic air bridge. Today, China's transport fleet projects sovereign power across oceans. The question is no longer whether they can build these giants, but how they will use them to reshape global influence. As these wings reach further, what kind of world will they help build? Share your thoughts below.